Now what this comes with is an API, which is what we're normally interested in, a programming interface that allows you to detect where your hand is and what the current state of the fingers are, or both sort of sets of them, so that as you move it, as you move, yeah, it can detect your individual finger movements. Now this is a rather sort of ham-fisted sort of approach. There's more delicate demos that involve sort of like little tiny grasps a bit. And the first time you see somebody using one of these, it's a bit like seeing your grandparents use a mouse for the first time, and bouncing about all over the screen or something. And it's the same thing with these. The first time you use them, you're really quite bad at it. So you're supposed to, in this case, just gently pick a petal. Do the old she loves me not. I always end up with she loves me not. Well, there are just a couple of the demos that come with it. You can get a load of things like games and other sort of demos. Like if you want to do actions like snipping or firing with it, you can sort of recognise those movements. There's ready-made games that come with it and activities. But as I say, from our viewpoint, it's better to write your own software. So you could have an interface to tell things to shut the door, or have an on-screen visualization of say a thermostat, and you turn it up with your hand to sort of work. Because people are gesturing with their hands all the time, and people understand lots of gestures. So we can sort of recognise what particular gestures mean, one or two and that sort of thing. Then these things can pick it up, particularly if you're differently abled, to be able to sort of recognise that. Great in games, great across a sort of a range of things. What we're always looking for is, from our side, yes, it's great to have a commercial use for it and great to play the games, but you're a bunch of programmers, you're a bunch of software developers, you want to say, how can I incorporate something like that into my own coding? How could I have that gesture control linked to, say, a motor, so you can sort of turn it around, or have it as a TV controller to sort of up the volume. Now I know we've got things like voice access, we've got the Amazon Echoes, ways around it. They're all just different ways of interacting, they're all just different ways of grabbing those senses out of your sensors to sort of work with. Now these particular ones aren't the fidget ones. I've interlinked it with the fidget ones. The Makey board, interlinked with it. The Makey one you can pick up from Maplin for about, I don't know, 25 or 30 pounds. But they're not sort of too much to buy. The Leap Motion one, it's about 60, 70 pounds. Again, you can get it from Maplin or probably from Amazon and the like for it. But a nice little interface to think about using. Perhaps if you're doing a project, integrated into your project to sort of work with for that. Anyway, enough of the plays for it. Last week I was on the intelligent data processing. That's really where I want to pick up from for today. We've sort of looked at in previous weeks the ideas of what happens with the operating system and something to do with networks and the like. What we're starting to look at here, and I just began this last week, was the concept of in-node data processing. Processing the data before you send it off. One of the things that you may have noticed from using those fidget sensors, they can be quite sensitive. They can be sort of blasting out data every time it sort of moves. So, particularly even for that slider, you only need to sort of just tap the desk and it thinks it's moved slightly. So you have to sort of scale it down. You might want to say only send it every 5 seconds, a time interval, or only send it when it changes by more than 10%. Light sensors or touch sensors can be sort of similar to it. So you may want to, before you actually send the data out, to restrict what data you've got, or to aggregate it, to fuse the data together at some sort of central point, like a sync node, that everything goes through, which can perhaps give the average of everything that's being sent out. So if I've got various temperature detectors around the room, I don't really need to know the temperature of every single one of them. I want the mean temperature for it. Something that just gives me the average for that. It might be a simple thing like an average, or it might be collating together and getting rid of bad values. Sometimes there's a little spike in a value as something comes through. So that's the sort of key thing that we're sort of setting off with last week, the idea of multiple sensors, broadcasting out in large numbers, perhaps sort of coordinated together. And I also looked at this idea of beyond conventional sensors, beyond the electronic sort of type things that we're dealing with, and looking into things like human beings as sensors, using Facebook or Twitter as a sensor, and perhaps picking up on data that people are sending inadvertently, just through sending some data saying, oh, this traffic's terrible today, or there's some incident going on Oxford Road. I've just got involved in something, and then if multiple people send that, then knowing things like location, things like sentiment analysis, you can judge on what's being said and the severity of what's being said, and perhaps sort of tweet things out, either through I'm stuck in traffic and doing sort of tweets from that and sort of analysing where that tweet came from. That's really been superseded by Google Maps to auto do that. If your Google device is constantly sending out your position, you can send out updates on how fast you're moving, even if you're not using Google Maps at the time. First time you use Google, any sort of Google application, they say, do you mind me sort of uploading your location to it? And so they're constantly uploading your location, not because they're interested in following you. Nobody's, don't flatter yourself, they're not interested in an individual. Yeah, no, not in you, I'm afraid. They're not interested in an individual. They're interested in what the mass of individuals are doing, where people tend to be going. If there's several people who appear to be on a road and they're not moving, then that's probably a traffic jam. And you can probably gauge how big that traffic jam is and display that on a map. So you could have done it through tweets and Facebook, but it's much more accurate to do it through an already existing one. So I finished off last week having a look at one of those tweet analyzers that took sort of millions of Twitter messages and did some sort of, say, sentiment analysis on it, looking for is that message positive, negative, is it something that somebody's excited, are they bored, for it, looking for certain sort of key words in what they're saying and classifying them in a certain way. And if it's tied in with location, then you can get all sorts of data. And just incidentally, one of the things that I've uploaded to Moodle for today, I had a project the other day. I mentioned about a sensor project for a guy who was a keen cyclist, and he sent off sensor data as he was cycling along based on sensors he was attached to. And the type of data that you are currently sending off for that, those lab works, you're sending off sensor name and sensor value, and it's storing the date, presumably in the database. You might send off an ID for that user. This was one of the structures he was sending off for each sensor. Each sensor sending off where it's to be published to. This was like an MQTT server that we'll look at. He's sending off the latitude, longitude. Now, you could easily do that in your own app at the minute, because your Android app, or any, you can get these little sort of plugins that can pick up your latitude, longitude, and broadcast them out. Which sensor model is it? How accurate is it? What was the date? What units is it measured in? So that's just a bit, it's the same sort of idea of what you're sending off, it's just a bit more comprehensive to sending it through. So rather than just sending off minimalist data, you're just sending off a larger chunk that perhaps other people may be interested in sort of working with. Because the other thing that I've put up, because people are having a bit of trouble envisaging what the assignments, say, look like, was a sort of block diagram of what you're piecing together, bit by bit. That over there on the top left, You've got your PC connected to sliders, RFIDs, whatever. You've got an API running on your local node, that's your PC, to it. That's taking that sensor data and then you're sending it off to a remote server where Tomcat's running. You're sending it using the HTTP protocol and you're wrapping your data up in JSON, hopefully, as you send it. And the remote server's doing something with it. It's storing it in a database. That's what we've currently got. Later on, we'll see how you can also store it in a message server so that other things are updated automatically. The motor servo, that's also sort of part of question one. Question one of these things on the left-hand side. They can retrieve data from the server. They're working with the Fidget API to sort of turn. They put in a request to the server saying, can you just get me the current position of the motor or some positional data that you want? And again, you get a JSON piece of data going back. And your local app then turns a motor. Last week you were working on, this week as well, we're going to spend another week on working on the mobile device. This question 2 of the assignment, your phone app, that's talking to the server, not to the database. There's a bit of confusion with some people about